Here is grade 7, module 1, lesson 1. Our I can statement for this lesson is that I can explain why relationships presented in tables, diagrams, and verbal descriptions can or cannot be represented by a constant unit rate. So what we are going to work on today is that constant unit rate. Here is the reteach that is available in Into Math. It starts with some vocabulary. So here we have rate. A rate is a ratio that compares two quantities measured in different units. So for example, we have like miles per gallon. Okay, something like that, miles per gallon. We also have unit rate. And that is a rate in which the second quantity in the comparison is 1 unit. So that's the big piece in this one, is that it's 1 unit. So miles per 1 gallon. Rate can be 2 different units. It doesn't have to be to the 1 in the denominator. And then we have constant rate. And a relationship is said to have a constant rate if the unit rate for all quantities in the relationship is the same. So that is what we're going to explore today. Here we have a table that shows how many pounds of a certain dog food you get when buying bags of dog food. So we're comparing pounds to in each bag. So here we have 8 pounds in 2 bags. And then 16 to 4, 24 to 6, 32 to 8, 40 to 10. If we compare these, we have 8 over 2, 16 over 4. Again, we're comparing pounds to the bags, 24 to 6, 32 to 8, and 40 to 10. And what do we notice about all these if we simplify them? Pause if you need to, do a little division. All of those end up equaling 4, every single one. Okay, and that's what we found here. Because each one of these ends up equaling 4, that means it has that constant rate that we talked about in our vocabulary. So yes, the unit rate is the same for every entry in the table. So the constant rate is 4 pounds per bag. When you are working with unit rates, you want to make sure that you know what you're finding. What are your units? What's in our denominator? And then our numerator, and then what's in our denominator. All right, here we have Charlie, who's doing a little babysitting, and we're trying to figure out if this relationship is a constant rate. So here we have the amount of money Charlie earned for babysitting is given in the table. Can the relationship be described by a constant rate? So we are trying to figure out the dollars per hour, the rate per hour. So here we have $45 for 3 hours of work, $75 for 5 hours of work, and $120, again, always knowing what these numbers are talking about, for 8 hours of work. Do a little division on the side of your paper here. Pause if you need to. 5 into 75, 8 into 120. What does that end up looking? And when we do this, we end up realizing that this is $15 per 1 hour. And that it is the same, it is the constant $15 per 1 hour and $15 per 1 hour there as well. So what we got is, yes, the ratio of dollars earned, 2 hours worked, is constant. For every part of our table that's given, it is the same amount. And that is that $15 per hour. All right, here we have a molecular structure of water. The ratio of hydrogen atoms to oxygen atoms in water is always the same. So here they tell us, when we read through our problem here, the ratio is always the same. So it is constant. How many oxygen atoms are there when there are 8 hydrogen atoms? So we're writing out our ratio here, write out what we know. We have 2 oxygen atoms for every, one oxygen atom. 1 oxygen atom for every 2 hydrogen atoms. And we're trying to figure out how many oxygen atoms there are when we have 8 hydrogen. Now we could, that's not a super high number. We could draw this out. We have 1, 2 already. And then let's see, 3, 4. So we have 1, 2, 3, 4, 5, 6. Need 1 more. 7 and 8. So when we figure that out, we see that we have 1, 2, 3, 4 oxygen. But what we can also do, if this number were bigger, we would want to know how to solve this without having to draw pictures. Say there was 200 or something like that involved, a much bigger number. We would want to identify what the relationship is between these 2 ratios here. So 2, how are we going to get from 2 to 8? What operation could we do? And what number would be involved? Pause if you need to, talk about it. We're going to need to multiply by 4. That's going to be our constant here, times 4, and that would get us our 4 oxygen atoms. So there are 4 oxygen atoms. 4 oxygen atoms for every 8 hydrogen atoms. All right, and that is it for our lesson 1 from Module 1, grade 7.